Thank you one and all for coming, especially certain folks that I invited specifically to be here. Thank you for attending. Tonight's talk is called 16 Nearly Impossible Issues for Evolutionists to Answer. And there's my email address should you care to use it later. The main objective is to sketch 16 issues which are mostly scientific. And my claim is that those responses from the evolutionists towards those issues fall short. And by that I mean woefully short of basic, well-known laws of mathematics, physics, and chemistry. This is a science talk, science all the way. So a few preliminaries, not in any particular order necessarily. When I was in History of American Education class many years ago, we were treated to a lecture which frankly had not much to do with education, but did have to do with 4 philosophical schools of thought. I want you to keep them in mind as to how we determine whether something is true. The 4 are absolutism, which means that somebody said so; empiricism, which means somebody tested it; pragmatism, which means that somebody discovered that something works; and existentialism, which means somebody found that something occurred. And the preferred choice for this talk, because it is a science talk, is empiricism. Here's a statement from the Backyard Skeptics. I love this statement. It says, "We need empirical evidence of any claim to accept it as true." I agree with that statement. Not to be an evidentialist, but I agree with the statement. Empiricism is rather the dispassionate interchange. It includes such things as the scientific method, whether our model agrees with reality, which would be the pragmatic aspect, collecting, measuring, observing, testing, correlating, cross-correlating, always under the ever-present questioning skeptical eye. And I understand that we do have some skeptics here, and I welcome your questions in due season, and thank you very much, those of you who came. We also modify our conclusions by repeating the above steps and revisiting our hypothesis and theory. And one very important point is that in empiricism, there's no such thing as exactly 0 or exactly 100% probability. We may have a high probability, we may have a low probability, we may have something in between. If you want 0 or 100, you'll just have to go to some other school of thought, I'm sorry to say. There are certain categories that are not empirical either, such as the historical, the spiritual, and the unsensed. We fully recognize that such categories, and maybe others, fall outside the bounds of science, and other criteria must be applied instead. Here's a quote you may recognize from The Blind Man and the Elephant. "Though each was partly in the right, and all were in the wrong." This is the 6 blind men that were evaluating the elephant from what little they could see. And science is often like that. We see a very, very little part of the elephant in the room. It's from a famous Indian legend. And let's also keep in mind that according to Thomas Edison, who had more patents in his day than probably anybody else, we don't know 1/1,000,000% about anything. Here's a general scientific principle. Verified scientific laws don't displace other verified scientific laws. So if somebody comes along and says, "I have this newfangled thing," ask them, what about the old stuff that we know is true first? Translation: the new science better agree with the old science, as Stephen Wolfram found out from his 3 skeptical professor colleagues when he visited his old alma mater on 1 February 2003. And I was there to see that interaction. There's another thought that we have to bring to the table. Extrapolation is similar to interpolation, except that extrapolation is much more likely to encourage mischief. By the way, who knows what extrapolation is? Could somebody over here? Yes?
It's extending a set of observations to perhaps the future or to an area not observed, and assuming the trend we see will continue.
Beyond the bounds, yes. And interpolation, who else? Somebody else be able to say what interpolation is? Anybody? Yes?
Well, it's just the opposite. It's within the bounds of observation to expect data to be between other data.
Filling points in between, yes. It's hard enough to do interpolation when there is no universal interpolation method. How much less when we extend back into the unobservable, unrepeatable past for extrapolation. I'm going to use a definition of evolution which is maybe not the one that is commonplace these days, but it is going to be more useful for what I discuss. Evolution just means change, and it can take on any number of forms, such as the ones you see, including biological at the bottom. Now, an evolutionist is a person, I would say, who holds to the view that every state of the universe can be explained by an unguided process, and it often leads to conclusions such as that the universe is getting better and better and better unabatedly. We'll see later that runs into some problems scientifically. In fact, it's going to run into problems when we review thermodynamics. Here are the actual books themselves. This blue book is Gordon Barrow, Physical Chemistry, and this one is Moore, Physical Chemistry, green. This is my undergraduate text and my graduate text. And it was in my graduate text that I learned a comedic way of viewing thermodynamics, shown in red. The first law is, the best you can do is break even. The second law is, you can only break even at absolute zero. The third law is, you can't reach absolute zero. The zeroth law is, you must play the game. And therefore the conclusion is, you must lose. Here then are the 16 issues, now that I've had those preliminaries out of the way. 1. Why does anything exist? 2. Did the universe always exist? 3. Did the universe cause itself to exist? 4. How can the universe avoid heat death? 5. How can any material travel faster than the speed of light? 6. What is the origin, transportation, and distribution of carbon? 7. How do any stars exist? 8. How do moons form? 9. What is the ongoing source of long-term comets? 10. How do any elements heavier than iron exist? 11. How do peptide bonds exist? 12. How do proteins have only L amino acids? 13. What turns non-life into life? 14. How does metamorphosis occur? 15. How do major morphological changes occur? 16. What creates information from gibberish? Now I'm sure that now that I have mentioned all the questions, everybody has all the answers and the meeting is over, right? No? Oh, you want to see some more? Oh, okay. Well, we'll see if we can accommodate that. The first one is, why does anything exist? Well, if nothing exists, we don't have any space, material, people, we have nothing. And from nothing, nothing comes. I would propose to you that maybe the starting point should be Roget's pocket thesaurus. It's more than just a treasury of synonyms and antonyms, and more than just its 1,000 categories for studying the language structure. Category number 1 is existence. Stands to reason, then, that the latter categories might have something to do with possible causes of existence. I mentioned Roget's thesaurus because it's probably the most neutral source next to the dictionary you can find. And yet, there is that interesting pattern to it. Not just why does anything exist, but why this particular amount of mass. It's been said there are 10 to the 80th atoms in the universe. Why not 10 to the 79th, or why not 10 to the 81st? And, a topic I'll keep returning to, why this particular distribution? In the universe, on the earth, wherever. It's not uniformly distributed. Which is what we might expect if we had, oh, I don't know, maybe a large expansion called a Big Bang or something like that? Maybe. Also, why does the amount of matter greatly overwhelm the amount of antimatter when we would expect to see an equal amount of each? I'd like to also mention something about quantum fluctuations. That's the theory in the popular parlance that says that nothing turns into everything. Really? What happens when nothing supposedly turns into a particle and antiparticle, and then the particle and the antiparticle come together? What will happen? Right, the particle and the antiparticle will annihilate each other and form energy. If we repeated that process indefinitely, we could turn nothing into unlimited amounts of energy, which would be clearly a violation of the first law of thermodynamics. Rather, what is actually touted is that there's an already existing energy field out of which the particle and the antiparticle come and to which they may return. But then there's no explanation for the energy field or its existence, let alone its cause. Number 2, did the universe always exist? No. Else we wouldn't be here. Everything would have already dissipated an infinite time ago. The universe, therefore, is either open or closed. If it is open, it could allow outside entities, maybe a god, in. On the other hand, if it is closed, then there's no escape from the thermodynamics. 3, did the universe cause itself to exist? I've had people answer the previous question, did the universe always exist, in the affirmative. And then when I show that that's not possible, when I get to this question, they also answered this one in the affirmative, even though it contradicts their answer to the previous question. No. Otherwise, the universe, catch this, would have had to have existed before it existed to cause itself to exist. Or the universe would have had to exist and not exist at the same time and in the same context. It's a logical contradiction either way. Reason it this way. Did this cause itself to exist? Did anything cause itself to exist? No, it'd be a contradiction for the same reason. So if not any one thing caused itself to exist, why should the sum of all those things cause itself to exist? And by definition, that's what the universe is. Everything. Oh, by the way, some people say that there's more than one universe. Well, I would return first of all to the fact that universe means everything. But if there is another everything, I would like to see the evidence for it. That's only fair if I'm an empiricist and you are an empiricist. I can take these issues 1, 2, and 3 and form what is called a cosmological argument. By application of issue 1, did the universe exist? We'd say yes. 2, did the universe always exist? No. 3, did the universe cause itself to exist? No. Therefore, within just those few questions, I have ruled out all possible material causes to the universe, because everything else would have to be a subset thereof. We only have 2 alternatives then. Either the universe has no cause, in which case it is unscientific. You're an Eastern mystic. You belong in the camp of existentialism, which we saw as one of the earlier schools of thought. The only other alternative is that the universe still has a cause, but it must be immaterial. Choose from the following possible list of immaterial causes. Fairies, leprechauns, gnomes, my favorite, flying spaghetti monster, God. You add to the list. Oh, by the way, only God even has any testimony. So, when somebody comes along and tells me that my theory is no better than that of a flying spaghetti monster, I will turn to that individual, kindly, hopefully, and say to him, I don't believe in flying spaghetti monster. You do. And I never get an argument at that point. It is not the creationists who believe in flying spaghetti monsters. Interesting way of turning the table on somebody who says something like that. We can also rearrange these blocks to form a water flow. Issue 1, does the universe exist? If you say no, you belong in an insane asylum. So we say yes. Does the universe have a cause? No? Then it would be unscientific, in which case we would conclude yes. Is the cause material or immaterial? Let's assume for the moment that it's a material cause. Issue 2. Did the universe always exist? If you say yes, that would violate the second law of thermodynamics. So we'd say no. Issue 3. Did the universe cause itself to exist? If you say yes, that violates logic, as we saw earlier. So we say no, the cause must be immaterial, and we're back to the immaterial choices. Stuff is powerful because many people do not understand that there are only a few decisions that need to be made. It's not as if somebody could say, we don't know. We do know that there are only a handful of decisions. And this is the entire set of choices. There aren't any others logically possible. 4. How can the universe avoid heat death? From the foregoing, we've seen it can't. It's a consequence of the second law of thermodynamics. And Le Chatelier's principle guarantees it. Let me explain Le Chatelier's principle in a moment. Let's suppose that this room became shocked for some reason. Maybe an explosion, maybe sudden heat. What happens when the shock has left the system? Well, the system in this case will return to its ambient state before that with the addition of the shock. And it will not stop until it has reached that point. It won't stop halfway or a quarter way there. It will go all the way to completion. So when we speak about the universe avoiding heat death, we're speaking about the complete dissipation of the useful energy. There won't be any left. Contrary to what people like Roger Penrose has been advocating lately, I would say, in his book Cycles of Time, which was released a few years ago. Is there any hope for a constant steady-state universe? Well, I would say the new science better agree with the old science, and in the old science, the thermodynamics are still there. You still have to contend with them. 5th, how can any material travel faster than the speed of light? Well, maybe you thought that they couldn't, because there's no observation has ever shown any such behavior. Again, contrary to certain schools of thought these days that would indicate so. However, those advocating a Big Bang without a Roger Penrose solution would be advocating also what I would call a hyperinflation at, say, about 10 to the minus 31 seconds. That's where the universe, rather than expanding at its current rate, instead expands vastly faster than the speed of light for just an instant, and then it slows down to where it was before. How does anybody know that it's true? And why would we need it in the first place? Well, it's to agree with outer space's stationary 2.7 degrees Kelvin. Otherwise, there's no way to communicate heat from one end of the universe to the other. But how would we even know what time it is? I've even seen variations on the amount of time. Why not 10 to the minus 32 seconds or 10 to the minus 30 seconds? We weren't there to observe it. How do we know? And why only at one time instead of a number of times? There's also a problem that was believed to be solved in 1982 called the graceful exit problem. That is, how to get it to go from its hyperinflated state to normal inflation. Well, maybe, maybe not. I don't know if any of you have ever heard of Hugh Ross's Reasons to Believe. Good chance you have. I asked their group, unfortunately I didn't get to talk to Hugh himself about this problem. They have no answers to it. Nor do they have any to the next issue. What is the origin, transportation, and distribution of carbon? I'd like some help from the audience, please. This picture shows, or the examples are invisible, what kinds of examples of carbon? One example per person, please. Anybody? An example. Somebody who's not talking before. Yes, in the corner over here.
Graphite.
Graphite is one. Some would say coal. Another? Who else raised? Yes?
Diamond.
Diamond is another. What else?
Coal.
No, we already said graphite and said that's the same thing. Any others? Come on, look very carefully.
The moss, the grass.
The moss, sometimes I call it chia pet material. Yes. What else? Anything else?
Carbon dioxide.
Carbon dioxide, which is not visible. Anything else? Yes?
Methane.
Methane. Terrific. You're the first person to come up with that one. Who? Anything else?
Us.
If I could see some, I grant you that.
Invisible, okay.
Yeah, petroleum is not normally invisible in the atmosphere. It's still liquid. Yes, anything else?
Anything that's alive.
Well, we have the example of the geopet material, in any vegetation, in other words. Anything else? Yes. Yes?
About 1 billion organic molecules.
I'll leave it as saying, one that hasn't been covered, but somebody did get the last time I talked to it, is carbon monoxide. There are any number of examples of carbon, such as the ones we've named: coal, diamond plants, carbon dioxide, monoxide, methane. My question, when all is said and done, when we examine the fact that there are deep, long coal beds, there are a few concentrated diamond mines, and there's gases and plants all over the place, how do we explain this diversity? But I've got a bigger question. Where did the carbon come from in the first place? That was a problem that was supposedly solved back in the 1940s and 1950s and earned a Nobel Prize. It is stated to be the triple alpha process, which I will depict in a moment. We don't know really how it would have been transported to here, and I'll get to that in a minute, nor the distribution, but those are some suggestions. And here is a book which, at least to some extent, mentions certain problems of trying to accrete material one nucleon at a time in that connection. In the periodic table, we can locate carbon as being in that position on the second row, with boron to the left and nitrogen to the right. Now, notice that we would ordinarily have just hydrogen, which is on the left, turning into helium, if we're talking about a star. And there the process would end because, among other things, helium is a noble gas. You'd never be able to get anything else. So the suggestion was made. We have two helium atoms, which came from hydrogen atoms on a star. They form an atomic weight 8 species, which is very unstable, and before it can disintegrate in 10 to the minus 15 seconds, a third helium atom collides to form carbon-12. The process can occur only in one nuclear resonance, only in red giant stars, and can be disseminated only by supernovae. Here is the triple alpha process in depiction form. You can see the heliums on the left. They form an atomic weight 8, which is beryllium, and a gamma ray. And then to form the remaining, to combine with the remaining helium atoms to form the carbon, we also have another gamma ray. Roughly speaking, this is how the triple alpha process would work, but it has to work just like that. Let me read this quote to you. One of the most striking of such apparent coincidences was revealed with William Fowler's confirmation of Fred Hoyle's remarkable prediction of the existence of a particular energy level of carbon, that's the resonance, which, had it not existed, would have meant that the production of heavy elements in stars would not have been able to proceed beyond carbon, leaving the planets devoid of nitrogen, oxygen, chlorine, sodium, sulfur, and numerous other elements. In other words, everything beyond carbon, including carbon. That was what earned the Nobel Prize. And this, by the way, was from Cycles in Time by Roger Penrose, on page, I believe, 317. Nope, wrong page, 171. Okay, so how did the carbon get to here? I call it the original dark matter. Where's the nearest red giant star to us? 33 light years minimum, maybe 40. How is it going to get from there to here? And is it going to jet all of its material to the Earth straight away? If it's a supernova, instead we would expect to have it explode in all different directions, not any one particular one. Some people have even stated that there might have been a red giant star in the current solar system area. I'd like to see some evidence for that before proceeding. After all, we are empiricists, aren't we? But even if it were in this area, wouldn't the supernova have exploded the material out in all different directions anyway? This still leaves our coal beds to be miles deep, thousands of miles long, and unevenly distributed as unexplained, as illustrated by these world coal deposits. Notice that in North America, the coal deposits run along the Appalachians, they also run through the Midwest, and they also run from Montana into Canada. There are numerous areas, you notice, that would be just as viable for accretion of plants as those areas that have essentially no coal beds. Also notice that South America, with its Amazon region, should be teeming with life. No coal deposits there either, nor is there much in the way of any in Africa. However, there's lots in Siberia where you wouldn't expect to find much. Notice also that they are unevenly distributed where they are, which requires also an explanation. I have yet to see one from any camp, by the way, any camp. 7. How do any stars exist? Let's assume that we start with all the mass confined to an infinitesimal volume. That's a volume that's as small as you want, it's still positive, it's not equal to 0, and that you end up with a Big Bang. You may pose another scenario if you like, but let's start with this one. Let's recall what Newton's first law is. Can anybody tell me what Newton's first law is? Got any physicists out here? Any students? Any at all? You remember Newton? Newton's first law? Nobody? Give it a shot.
An object at rest will remain at rest until it's acted on by an outside force.
Oh, excellent. Or sometimes stated, an object at rest will tend to stay at rest, an object in motion will tend to stay in motion. What will happen to the particles with a Big Bang according to that? With the ever-increasing expansion? Well, what would we expect? According to that, the particles would keep going and going and going away from each other. What do we need to form a star, supposedly? They must be coming together and together and together. We have a hard enough time trying to compress gases here on the Earth. We have to have a specific compression device of much smaller volume, and the particles go, rather than from, they go from a hot state, relatively speaking, to a cold state. What would happen in outer space? The particles go from the frigidness of space, near 0 Kelvin, 2.7 if you like, to become hotter than the Earth, all on their own. And even if that were assumed, you'd also have a problem once you remove the compression device. Since it's a gas, the gas would still expand to fill the volume available, and it would not stay compressed. So in other words, we shouldn't expect to see any stars at all, if that's all we had to know. I know there are a lot of people who postulate a number of things, but I'd like to at least bring the old science back to the table and ask, what about that? Now there's a flip side also, and that is, let's assume a generous 20 billion years. Somebody's calculated, I don't know how, that there are approximately 10 to the 21st stars in the universe. Dividing the number of stars by the number of years, there should be an average of 50 billion stars being formed every year for every one of those 20 billion years. Somehow I don't remember seeing in the newspapers, on radio or television or on the internet, anything regarding us having met our quota of 50 billion stars last year. Now, if you find such an article, I'm an empiricist, bring it forth to my attention, and we shall be happy to look at it. Now, you might have more than 50 billion stars or less than, but you have at least an average of that much. 8. How do moons form? Just had a little piece on things like that. Let's assume that we even have stars and orbiting planets. I've got a silly question. How do you get a solid moon by blasting a gaseous planet? We've already seen Jupiter, Saturn, Uranus, Neptune. They are the gaseous planets in our solar system, and they have almost all the moons, too. All right? Well, then somebody would come along and say, what about the nebular hypothesis where everything was forming in the first place? Tell me then, why would the planets form to be gaseous and their nearby moons solid? But we have a moon around our Earth. Let's examine that matter as well. I'm going to take it first from the standpoint of a collision of some body into the Earth. What's the most likely thing to occur? It'll stay stuck in the Earth. And you won't have any possibility of a formation of a moon. Well, maybe it's traveling a little bit faster than that. In which case, you might have things coming out of the Earth. And by the way, it better not be hitting the Pacific Ocean region with an ocean there, because otherwise you'd be blasting an ocean out. Very well, the Pacific Ocean region without an ocean. It must exceed Roche's limit, which is about 1 to 2% of the height above the Earth. In fact, the particles will be fragmenting all the way up as well. In other words, the most likely thing is that they will come down in a shower, and there goes your moon experiment. But let's suppose that they actually congeal and compactify with no known source of the compactification. They would also then have to have a tangential velocity, in other words, perpendicular to a straight out coming, or else they won't orbit. We who have been in aerospace know all too well the exacting conditions for an orbit. I haven't seen anybody come up with an explanation for that. And even if you get the tangential velocity imparted, what's most likely to be the case if it's coming straight out of the Earth? It's going to be geosynchronous. It's going to orbit the Earth once a day. How often does it actually orbit the Earth? Once a month. That's how we got our name, month. On the other hand, the capture theory is regarded even these days as being too coincidental, in fact, virtually abandoned. And also, even if it were true, where is the evidence of other tries? You might remember a few years ago about a meteor we were all concerned about. Imagine what would happen if you saw a moon coming in your direction. So really, there aren't any plausible theories, I would maintain. Consider the following quote from Wikipedia. Since tidal forces overwhelm the gravity that might hold the satellite together within the Roche limit, no satellite can gravitationally coalesce, come together, out of smaller particles within that limit. I'll leave that up for the camera to capture. It's a little too long to read, but for those who hold to the capture mechanism, there are proponents on the other side who argue, because of oxygen isotopes, that that's not really going to work too well, and that would be another reason for that being abandoned. You may come up and examine this afterward if you are so inclined, and I'll provide it for you. 9. What is the ongoing source of comets, specifically long-term comets? Now, the short-term comets have an orbital period, elliptical, of 200 or less years, like Halley's Comet is one. They can be generally explained by what are known as the Kuiper Belt and the interplanetary disk. And some of the long-term comets, the ones with periods of greater than 200 years, can also be explained that way. But some of them can't. And it's those other ones that we can't explain for which the Oort cloud was hypothesized, spelled O-O-R-T. What might you ask? Is it Oort cloud? It amounts to being an automatic picture of dirty snowballs. Conveniently, of course, to account for the mass that's being lost by the planets, the comets rather, who are coming close to the sun and losing their mass there or elsewhere. There is no actual evidence for the Oort cloud, which would have to have a center way beyond the solar system, it's believed. And there's no other hypothesis offered yet. Sometimes when I think about the Oort cloud, I have visions of Santa Claus and the North Pole, because they're both far away and very cold. 10. How do any elements heavier than iron exist? Another view of the periodic table, this time focusing upon iron. Iron, as you'll notice, is in the 4th row It's between manganese and cobalt at element number 26. This chart is known as the average binding energy per nucleon. It can be found, among other places, in Chapter 9 of this elementary modern physics textbook, which I had when I was studying modern physics, the same year that I was studying that History of American Education course. Notice that to fuse elements to get them to be higher and higher mass, we encounter a number of ripples. One of them is right after helium. You might recognize that as being somewhere in the neighborhood of that carbon problem. And also, what happens when we get beyond iron, which is symbolized by Fe for ferrous? That would be the isotope with 56 as its atomic weight. What happens to the curve after that? It shrinks. It goes down, meaning that iron is more favored to form than any other element is favored to form. According to this curve, you'd have to have already existing uranium, clear with the other end, element U, atomic weight 235 in this case, although there are others, and you'd have to have fission bringing them back. What is the supposed explanation that would overcome all this? Our old friend, the supernova again. I have the same objection as I did with carbon. Wouldn't a supernova explode everything out into all directions instead of concentrating it into the ores that we see on the Earth and elsewhere? It would still not be economically mineable or viable. So we can go from hydrogen to iron with some difficulties, but we have problems elsewhere. And we don't have any explanation of the transportation and distribution either, much as we did for carbon. As illustrated by this world's mineral deposits, it's a little hard to see on here, but if you were to take a closer look, you would find that precious materials are often found in places like South Africa, Russia, or maybe China, creating interesting political controversies. 11. How do peptide bonds exist? This is a model, I hope you can see it well enough, of an amino acid. Let me point out the salient parts. On this side is a nitrogen atom connected to two hydrogen atoms, forming an amine group. On the other side is a carbon atom doubly bonded to an oxygen atom, and also singly bonded to an oxygen atom, which itself is singly bonded to a hydrogen atom. Carboxylic acid, COOH. This is a base, this is an acid. They should connect together. Bases and acids do. They should form a salt and water. In the middle, a carbon atom, the central carbon atom. On one side, another hydrogen atom. And this representation of a functional group, which may be either another hydrogen atom or any of 19 other groups. The way of joining two of these together would nominally take the following process. Notice that we have two amino acids in the upper left-hand corner of this diagram. They are actually both amino acids, it's just that the second one we have decided to show the hydrogen atoms more clearly. We would be combining the OH from the carboxylic acid of the left amino acid, sometimes called a hydroxyl group, with one of the hydrogens from the amine group in the right-hand amino acid. The two components then would form H2O or water, and water would be lost to the system, forming the peptide bond. We could continue to replicate that process until we have formed a chain, as illustrated along the bottom. That is how proteins would form. And that would be their pattern. I've got a silly question. Have you heard that tale that says that we came from a warm little pond? Just how is that going to occur when a water molecule must drop out, not be absorbed by the amino acids? This is a problem. Okay, so we don't have a warm little pond. I don't know how those two amino acids are ever going to find each other on dry land, but let's suppose that they would. We have two choices for our atmosphere. We either have an oxidizing atmosphere, oxygen is one such example, or a reducing atmosphere, which would be the other. If we have an oxidizing atmosphere, then the oxidizing agent will come along and destroy the bonds and maybe the amino acids along with them. On the other hand, if we don't have an oxidizing atmosphere, we would have a reducing atmosphere. We would not have ozone, and the UV rays would come in and they would destroy the bonds and maybe the amino acids. We have a chicken and egg problem, in other words. By the way, which came first, the chicken or its egg? God. But of the two, a hen and a rooster came first. It wasn't Adam and Steve Rooster. It wasn't Eve and Guinevere Hen. It was Adam and Eve Chicken. We need peptide bonds to form proteins. Without peptide bonds, we have no proteins, we have no enzymes, we have no life. And as we all know, without biochemistry, it's amino world. How do proteins have only L, which is left-handed amino acids? Let me illustrate what I mean by that. You might recall that we recently went over the components of an amino acid. The amine group, the carboxylic acid group, the hydrogen, the functional group. The geometry, however, permits there to be a mirror image amino acid. Do you see that these two are mirror images of each other? That is, that I could put a mirror right down the middle between the two, and one of them would be mirrored or reflected into the other? You see that? You could also look at the figure and see the same thing. The one thing you can't do is stick one on top of the other and match them for atom. They will not match. They'll be dissimilar. Therefore, these two are distinct compounds from each other. They have the same melting point, boiling point, refractive index, vapor pressure, chemical reactivity, density. All the environmental properties are all the same with one lone exception: plane polarized light. One of them will rotate plane polarized light so many degrees in one direction, and the other will rotate plane polarized light by the same number of degrees in the opposite direction. What would happen if I started with neutral ingredients, neutral energy source, a neutral environment, whether it was organic or even inorganic compounds possessing these properties? What would we have? We would have an equal probable mixture. That is, half of it would be left-handed and half of it would be right. You might be able to cause a small diversion by using something like soil clays. You might get as much as 1% variation. You might also have something more radical like the Murchison meteorite, which hit Australia on 27 September 1969, which had a much greater imbalance. But what you will not have is 100-0. And yet, every amino acid in every protein of every species is only left-handed. There are no right-handed ones anywhere. Among the books that I illustrate that with is James F. Cabbage's Evolution, Possible or Impossible. I believe that in this audience we have the son of James F. Cabbage, who introduced me, in fact. I found this problem during the first week of class in this textbook on page 14, Streyer's Biochemistry. All I would say is they're all left-handed, and then we're going to move on to the next topic. It said nothing about the problems, which took me no difficulty to realize. How are you going to get all of them one way instead of the other by a natural process? I don't know how that would be done, and I don't know of anybody else who would either. These are my surviving copy of the bottom book called Flaws in the Theory of Evolution, written by a prodigy of a doctor known as Evan Shute, who worked on things like vitamin E in the 1930s. How far back that goes. And in that textbook is a statement by an evolutionist regarding how many proteins we would expect to form at all. Have any idea? 3. That's it. That's a far cry from getting anything close to 1 cell. What did Isaac Asimov have to say about it? Nothing scientific. If I had heard him say what he apparently did in his article, it just happened that way, I read the article too, I would have said, across the entire face of the globe? No, they don't replicate and chain together like that. That's not what happens. Now, right-handed or D amino acids do exist in other structures. Bacterial cell walls to keep enzymes, which are proteins, which are left-handed, from destroying them. By the way, if a bacteria encounters a right-handed amino acid, it turns into a left-handed amino acid and then digests it if it can digest it. That's how the preference works. For those who have an academic inclination, we also can go to the matter of computing the bond angle at the central carbon atom. If all the components are equal, we can prove by high school geometry, Euclidean geometry, that the angle is equal to the arc cosine of -1/3, or 109 degrees, 28 minutes, 16 seconds. If you have any students who are interested in a slightly advanced topic who are taking geometry, I would recommend that you go and show them how to compute this bond angle. We didn't see it until we were freshmen in college, but it can be done a lot earlier, and I wish they would. If you don't have equal components, then you might have a better idea of your functional group by reason of the stretching or compression associated with the bond. In the top right is a picture of my sophomore organic chemistry textbook by Morrison and Boyd. It's a standard textbook. On page 236 is a statement regarding these difficulties. Some people call these compounds optically active, stereoisomers, chiral compounds. Indeed, we deal with optically active substances to an extent that we may not realize. We eat optically active bread and optically active meat, live in houses, wear clothes, and read books made of optically active cellulose, the proteins that make up our muscles and other tissues, the glycogen in our liver and in our blood, the enzymes and hormones that enable us to grow and that regulate our bodily processes, all these are optically active. Naturally occurring compounds are optically active because the enzymes that bring about their formation, and often the raw materials from which they are made, are themselves optically active. As to the origin of the optically active enzymes, we can only speculate. The situation is no better now than when this book was being printed in 1972. And the problem was known for more than 100 years before that. You might also ask, what about mixtures of lefts and rights? Well, the book that I referred to earlier, Evolution Possible or Impossible, rules that out because it just doesn't work too well. But there's no reason why we couldn't have all right-handed chains. They form equally well under neutral conditions as left-handed ones would. 13. What turned non-life into life? Suppose I give you a dead dog. It's been dead long enough, 3-4 days. One small task, Hercules, breathe life into the dog. I've given you everything that it has. Brain, heart, lungs, liver, spleen, nervous system, gallbladder. Just breathe life into it. What's the matter, Hercules? Is this not a small task? Are you not Hercules? Well, maybe the problem is much bigger after all. And if we can't breathe life into a dead dog, what makes us think that we can breathe life into materials made into a dead dog? And we have far less than that if we only have hydrogen, or maybe that infinitesimal before the Big Bang occurred. There is no spontaneous generation. There is no Goldschmidt hopeful monster. There are no scenarios about RNA doing all the work that have succeeded beyond the hypothetical stage. Life only comes from life. That's all we've ever known since Pasteur. 14. How does metamorphosis occur? There are two different kinds. One of them is amphibian. I will be referring to one aspect of insect metamorphosis. Here is a life cycle of insect metamorphosis. We see the egg, the larva, the pupa, and the adult. Suppose I give you 3 of them. I'll get to pick which 3, though. Suppose I say that I'll give you that an adult can lay an egg, that an egg can turn into a larva, and that a larva can form that cocoon around itself, or chrysalis, to form a pupa. Would somebody please tell me how that pupa in its mushy state, without any control of its destiny, turned into an adult? I have quotes from all 3 camps, the young Earth, the old Earth, and the evolutionists, all within the last 5 years, to indicate support for the contention that it is still a mystery. And ignorance is no answer. If you tell me, well, we'll just wait until science finds out because we don't know now, I'll just wait, and wait, and wait. I don't have the burden of proof. It's the ones making the claims who do.
We might want to look at metamorphosis. Most insects, about 87%, undergo a complete metamorphosis. That is, a larva, such as a caterpillar, builds a cocoon or chrysalis around itself. Its body inside then disintegrates into a thick pulp-like liquid. Days, weeks, or months later, the adult insect emerges, one that is dramatically different, amazingly capable, and often beautiful, such as a butterfly. The food, habitat, and behavior of the larva are so different from those of the adult, it's hard to imagine. What mutations could improve a larva? Certainly none that destroyed its nerves, muscles, eyes, brain, and most other organs, as occurs within the cocoon. So even if the larva improved, it later ends up as mush. From the evolutionary standpoint, liquefying complex organs is a giant step in the wrong direction. Millions of changes inside the thick liquid never produce something survivable or advantageous in the outside world until the adult completely forms. How did the genetic material for both larva and adult develop? Which came first, the larva or the adult? What mutations could transform a crawling larva into a flying monarch butterfly that can accurately navigate 3,000 miles using a brain the size of a head of a pin? Indeed, why should a larva evolve in the first place? Because it can't reproduce.
John David Lehman. 15. How do major morphological changes occur? Here's a pictorial chart showing how evolutionists have often viewed going from one to the next to the next. Let's see what would happen. If you had a fish turning into an amphibian, you would have to go from no metamorphosis to metamorphosis, a heart that's 2-chambered to 3-chambered. From an amphibian to a reptile, we would have to reverse the metamorphosis so that we don't have any left anymore, and the fertilization would have to go from external to internal. If we want to go from a reptile to a bird, it would have to go from cold-blooded to warm-blooded and scales to feathers. If from the reptile instead to the mammal, we would go from scales to hair. And if you wanted to pursue the alternative, which nobody does as far as I know, birds going to mammals, then the wings would have to go to hands, paws, or hooves, and the feathers to hair. Not one of these transitions has any reasonable chance of being solved anytime in the near future, if ever. Now you might ask, what about those little incremental changes that any one of them could have within itself? Like say fishes, or reptiles. The point is, how many ever gradations you might have within that much, there still has to be a point of transition from one to the other if the scheme is to be valid. And it is at those points of transition that I identify these weak spots.
Well, never mind, evolutionists still insist that feathers evolved from reptile scales, specifically dinosaur scales, and to prove the point, they say that feathers and scales are so similar you can hardly tell them apart. Have you noticed that? One of the first people to say this was Gerhard Heilmann back in 1927. In his book, The Origin of Birds, he says the most striking peculiarity of birds is their plumage, which apparently has nothing at all in common with the scaly covering of reptiles. So much more surprising is it, on examining these structures in the microscope, to learn that the feather is nothing but a further development of the scale. Alfred Romer, very distinguished evolutionist, says birds have been called glorified reptiles. Feathers are in reality almost their only distinctive feature. And he says, although these structures seem quite different from the horny scales that cover reptiles' body, the difference is in reality not very great. Well, you can look in your Encarta encyclopedia, if you have one on your computer, look up feathers, and they will confidently declare that the feather is a horny outgrowth of skin peculiar to the bird, but similar in structure and origin to the scales of fish and reptiles. So I thought we'd do a little test. I had a laboratory technician that worked for me. They had a pet boa constrictor. And I said, hey, the next time that little rascal sheds its skin, why don't you bring it on in and we'll look at it in the microscope, because I understand you can hardly tell a reptile scale from a feather. And so she did. She waited, and when this little rascal shed his skin, and by the way, I want to point out that no snakes were destroyed to do this study. We waited until they shed naturally. She brought the skin in, we put it under the microscope, and we magnified it. And this is what a boa constrictor scale looks like here. You can see the others around it. And as the evolutionists have told us, if you look at them in the microscope at least, they are remarkably similar to a feather. So then I took a picture of a feather, and I want you to see if you can tell the difference. So you may want to clean your glasses or something right now. If you got this one in mind, okay? If you get confused, just look at the top. It'll tell you which is which. Okay, that's the scale. This is a feather. What do you think? Should I go back and forth? You got it down, or... I mean, why do they say they're similar when they're absolutely not similar? In fact, I'll go further than that. They are totally different. Their mature structure is dissimilar, their function is dissimilar, their embryological development is dissimilar, their mechanism of growth is dissimilar, their mechanism of replacement is dissimilar, their chemical composition is dissimilar. And let's just look at the obvious. Scales are like folds in drapery, like drapery pleats. It's all one sheet. That's like when a reptile sheds scales. He doesn't shed them one at a time or two at a time, does he? The whole thing comes off as one sheet. In fact, reptiles typically have two layers, won't they? An outer layer and an under layer. When they shed the outer layer, then the under layer is exposed. Why do they do that, by the way? Why do they shed their skin? Because they're growing. Now, I want you to think about this. You get a box through the mail, and you're wondering what's in the box. You open up the box, you know what's in the box? A bigger box. So you shed the outer layer because the under layer is bigger. You got to think about that a while. Let's look at that boa constrictor skin. The tail's in the direction of the arrows. So to your upper right, that would be the tail. I don't know, quarter of a mile up there or something like that at this magnification. And you can see the scales are arranged in rows, sort of on the bias with the long axis of the snake. If we get a hold of the right side and flip it over like the page in a book, this is what the underside of the skin looks like. And so now the tail's in the direction to the upper left corner. And again, for those of you in the cheaper seats, let's magnify this a bit. This is where one scale just fit right underneath here. It fit right in there, so when the skin pulled off, that scale pulled right out of that pocket, like taking your hand out of a glove. And that's the way the scales are put together, is one continuous sheet. Now, feathers are completely different. Feathers grow out of follicles, just like hair. Hair grows out of a hair follicle. Feathers grow out of a feather follicle. But I'm here to tell you there's no such thing as a scale follicle. Now, what is a follicle as it relates to feathers and hair? It's a tube-like depression in the skin. You see it here. Goes down deep in the skin. All of the growth occurs in the bottom in what's called a growth collar. The feather grows out sort of looking like a thick hair. And when it comes out of to the surface of the skin, it all unfolds to make the feather. This is the way the feather follicle looks down in the skin. All of the growth is occurring here. And the feather's alive at this point, but as it makes all of its parts, it dies. It goes through a programmed cell death so that the feather that emerges from the skin is completely dead. This is how it all develops. Inside the shell here, we have what we call a pin feather. If you peel this shell away, you can see that this is the growth region at the bottom. The shaft goes up along the backside there, and then the barbs grow off this growth ring. And those little barbs get longer and longer. They grow from each side and meet at the other side. When the feather comes out of the follicle, this cylinder opens up, the barbs all swing down, and you get this big broad feather out of a hole in the skin that's not much bigger than a shaft. And that's the way each feather grows from living cells, goes through a programmed cell death, and rises up out of the follicle in that way.
Dr. David Benson. Before going on to the next topic, I'd like to read something from Laws in the Theory of Evolution at the end of the second chapter, Mechanistic Origins of Life. At the end is a summary that says, surely all these considerations illustrate the complexity of the problems and difficulties faced by the evolutionist and anyone who thinks that life arose of itself and ever since has developed on its own. One must remember at this juncture how many of these evolutionary suggestions used as arguments about are based upon the most tenuous possibilities, not probabilities, just possibilities, and how step after impossible step is begged in the course of these polemics, which are really more in the nature of intellectual exercises than science. Because scientists enjoy playing such a game of chess, the game does not become truth. It is still just a crossword puzzle or a problem like that of a sonneteer who undertakes to discuss the dictionary thoroughly in 14 lines, which must end in certain specified rhymes. A long succession of elaborate postulates, such as we have listed in this chapter, and which are necessary, mind you, if the evolutionist is to be consistent in his survey of all of life, including its origins, is still science fiction. This was written in 1961. And this is true today as it ever was. I'd also like to say something about the author, as I promised earlier. Dr. Evan Chute has written an intensely interesting book, which brings to light an amazing number of difficulties for those who accept macroevolution as an adequate explanation of the world of life. ... Dr. Chute, a fellow of the Royal College of Surgeons of Canada, received both his undergraduate and medical degrees from the University of Toronto. It is interesting to note that Dr. Chute was more or less of a child prodigy. So was his brother, I understand, too, who also became a doctor. Entering high school at 9 years of age, he matriculated at the University of Toronto at the age of 14, the recipient of a Carter Scholarship based on a record high score. That's Doogie Howser. An all-round athlete, he was intercollegiate light heavyweight boxing champion, a member of the wrestling and track teams, as well as of the college crew. Hulk Hogan. He is a member of many internationally known societies, including the Canadian Physiological Society, the American Society for the Study of Fertility, the British Society of Endocrinology, the American Geriatric Society, an associate member of the Royal Society of Medicine, and a member of the Canadian Authors Association. He is listed in American Men of Science, American Men of Medicine, and Canadian Who's Who, Dr. Shute is a lecturer of international renown, the author of numerous books of verse, and the editor of Summary and Annual Medical Journal. Does that sound like somebody who has an irrational view of the world? If you still think so, let me know why. Meantime, I'm going to go to the next and final topic. 16, what creates information from gibberish? You might recall from your communication class or your engineering class that communication requires a sender tuned to a receiver tuned to the sender, and a medium which promotes rather than interferes with that communication. It also would be helpful if the sender and the receiver were to perform a task to prove that in fact they were communicating. How do we measure things like this? Let's suppose that I just start with a bunch of numbers scattered about. How would I conclude whether or not that set of numbers looks to be like a bunch of tiles thrown together, as we saw earlier, or something that may resemble a pattern? Well, we have measures such as the autocorrelation function and its glorification called the ambiguity function, which I won't go into at this point, but I can tell you that if you want to find out more about these, you can pick up any number of books, including this Radar Handbook by Marilee Skolnick, which is a reference material in virtually every aerospace company in the world. Meanwhile, we have something else that looks like entropy, our measure of disorder, when it comes to information. Instead of heated gases, we have scrambled quarks. We need information for life structures. We need the DNA to code for the proteins for the DNA. How would we ever get one to code for the other and the other for the one if we only had one, for example? And even if you did, how would you get them to talk to each other? This is, in other words, another chicken and egg problem. There's some pictures of a more modern version of the text, and Dr. Skolnick himself. Before going on to these pictures, I would like to mention that this talk began with information when I pulled out Roget's thesaurus. I would contend with you that it has now ended with information and the cycle is complete. Who recognizes any of these 7 famous modern scientists? One at a time, please. Anybody? Yes? Do you have a suggestion? Which, if any of them? Speak up, please. The first what?
He said Isaac Newton.
It is the first what? The first scientist on the left? Yes. Is which one?
Which picture?
Oh.
No. Yes. Would be which one? Top left is Johannes Kepler, yes. Who else?
Second from the left is Isaac Newton.
Second from the left is Isaac Newton, that's correct. Yes.
Louis Pasteur, bottom middle.
Bottom middle is indeed Louis Pasteur. Who else would like to take a shot? Yes.
Michael Faraday, far right.
Michael Faraday, far right is correct. We've got a sharp crew here. Let's see, I would like to take somebody who hasn't answered yet. Anybody? Anybody? Okay, then I'll take you. Go ahead.
William Thomson, Lord Kelvin, bottom right.
Which one, please?
Bottom right.
Is,
William Thomson, Lord Kelvin.
it is, yes. William Thomson's is given name, and Lord Kelvin is honored name, yes. Any others you'd like to venture a guess on? We have two left, and they are both as famous as the others.
We give up.
We don't give up. We have another possibility here. Yes?
James Clerk Maxwell, bottom left.
Correct. James Clerk Maxwell. We have one left, the one in red. He was stated some months ago to be supposedly more influential than Jesus. I don't know that I agree with that. Maybe our skeptical friends might say so.
Francis Bacon?
No.
Linnaeus.
Linnaeus. I don't know what kind of a prize to give you for having gotten 3 or 4 of them.
He's a ranger.
What else did they have in common?
They were all
He's a cop.
At least they were not evolutionists. Some people back in those days were, but none of these was, and not very many others. In fact, here are 16 famous modern scientists to counter the 16 nearly impossible issues. Of course, one could list many more than that. Here's a list of references that I used. Only the 3 in green would be considered to be favorable to a creationist position. The others are neutral at best. Maybe not even that, especially with the case of cycles of time. There's nothing better than having the people on the other side of the aisle agree with you, whichever side of the aisle you're on. I would like to give some credits for some of the slides. Joe Emilio was very instrumental, as Tom Canfield is our cameraman down south, and Ted Williams, a Navy SEAL who has a book called Seal of God, which came out April 21, 2012. He supplied more than 2. The end. Do we have any questions from the audience? Is it time for Q&A? Yes.
I think it was your 5th point. Why doesn't the universe die a heat death?
4.
I grew up with the idea that energy can neither be created nor destroyed.
Mm-hmm.
Can you elaborate on those 2 ideas? They seem to conflict each other.
Well, I don't know in what way they would conflict with each other. To say that the energy itself is neither created nor destroyed says nothing about what becomes of that energy. The second law is that the energy that is neither created nor destroyed becomes less useful, becomes more random, more scattered. It is still there, but it is less useful in the form that it is. Take, for example, when you go from a hydrocarbon and burn it, you end up with carbon monoxide and water. It's the same elements, but the useful energy has been stripped from it. You might recall little things having to do with kilocalories per mole, maybe, as being measures of it. Does that answer your question?
Yes, sir, it does.
Yes, we have another question?
This is regarding the formation of peptide bonds. You said every time that forms, water molecule is formed.
Water molecule is dropped out.
It's dropped out, right. And you had mentioned that life couldn't have begun in the warm little pond, because why would the water molecule drop out? And I'm not quite catching the connection there. So
Because the water molecule, because the water would prevent the water molecule that is there from the acid and the base from never dropping out. They would just remain as starting materials. In fact, you have to have a specific device. I understand it's called a ribosome in the endoplasmic reticulum that has to essentially zipper things to force the reaction to occur. Otherwise, it won't. Yes?
You're also forgetting that DNA, the sugar, backbone sugar, is an R form.
Mm-hmm.
So there you are.
I didn't forget it. I just didn't mention it. Yes, another question.
No, it's kind of still regarding the formation of water molecule. Is that somehow related to the shot name? Because there's water already there and no more water molecules formed? Is that the deal there?
Well, Lashani's principle more has to do with shocking a system and what happens after that it returns to a state of equilibrium.
Right.
One could always invoke Lashani's principle at any given moment. I would have a harder time seeing how that would be a more direct application in this case. But one could, if one wanted to, I suppose. Another question, yes?
Well, it relates to hers. These, like so many others, are reversible reactions. So if you've got a lot of water around you, is going to want to intrude and break up, as they say, break up the tube rather than come out.
It will eventually, although the reaction time is slower if the bond is already formed. Also, in practical terms, a protein may have been surrounded by fatty deposits, which would prevent the water from now attacking it. Yes, another question?
I would only ask, rather than spending all this time challenging evolution, and I don't understand any of your science, so I can't argue with you about that.
Yes.
Why not just accept it as God's method of creation? You believe in creationism. Why not accept this whole procedure as the way he did things?
Well, if I were going to speak on the other side of the empiricism, I might give credence to saying such things. The purpose of this talk, however, is to stay within the bounds of empiricism, which is the recommended method in science, and to see what becomes of things as we examine just the facts. And by the way, Joe Friday never said just the facts, man. In spite of all the Dragnet episodes that are now on the air again at 11 p.m. So I would say that the main purpose of this talk was to stay within the bounds of science. We could explore other possible avenues, and we should be happy to do so if there is reason and room to do so. If you'd like to, with me, for example, sometime.
Oh, yeah.
Oh, I'm sure you would. I'm sure you would. Any others? Any other? Yes?
I have a question on 12, maybe 12.5 would be why are usable sugars only right-handed? Could you develop
I believe that was proffered by somebody in the back. It didn't come out the same way. Yeah, there are other kinds of optically active substances that one could mention. In the case of sugars, I believe it is almost all of them, not quite every single one of them. So I usually don't...
Can you name an exception?
I can't offhand, but I believe that's the correct statement. In any event, I do not discount the fact that almost all of them do, if not all of them. And you would have a similar problem. However, I believe it suffices to use a simple example now. The amino acids, the sugars are a little bit more complicated than the amino acids are. Yes?
You know, that gentleman who said he doesn't understand your science, but why can't God use evolution? So my argument to talk to him about that is, number one, we know that Paul always said, and Peter, all the disciples, you should have an answer to your faith, to understand it. If you go along with current scientific information, which will change tomorrow, which will change on the head of a pin, what we knew during the time of Darwin to we know now, we've got scanning EMs, and he's going to look at structures and molecules. He didn't have any of that. So all of a sudden their ideas changed, everything got more complex. The idea is this, is that if you base your life and your information on the latest scientific information, it proves God to be wrong, and you're trying to fit the Bible and God into that picture, it's going to have to change again. So where's the information that we want? The Bible itself is the reliable source. It's a history book. It's not really a science book, but it is somewhat in some aspects. And so, to try to fit human knowledge into the Bible is what we're trying to do. He's trying to say, well, if all scientists believe in this, then it must be true. Well, they don't all believe in this. And you have to use your logic. And you do have to know a little bit of science. You can't just say, well, I don't know your science, but why can't you use evolution? Well, you got to know a little bit. You got to have an answer. You got to look deeper. You can get some very simplistic books that can talk about the evolution-creation controversy. This is what I'm just trying to say. Don't just dogmatically accept what the current science is today. It's going to change again. And it's going to make a big difference as far as it shouldn't make any difference to us.
Points taken. I would defer to making any comments about them because they're simply from another camp, just as his are, and I would like to at least promote rather than deflect from a collegial atmosphere, which I believe we have been successful in maintaining until now. You could afford a dialogue if you care to later on. But as far as the scientific enterprise is concerned, it's a very exciting one, and we should be thrilled that we have, in fact, been allowed to make such discoveries. I would like to also say something about that enterprise, though, which I haven't said till now, but I have said in other talks. If there's anything that we should be doing, and that is favoring the things that are the more probable rather than the less probable. Right now we have a situation which my estimation is that the impossible becomes the possible the plausible, the plausible the probable the certain. This is not science. Show me why the impossible becomes the possible and so forth before going any further. Otherwise, we're saying we believe in miracles over science. That's not empiricism either. Another question or comment, please. Yes?
If you don't accept evolution as true, do you then think that the God of the Bible is true?
Well, certainly it has to be accounted as a choice, otherwise it's not a complete panoply of all the choices. But as far as all I'm trying to do in this particular case is to provide factual discussion, if you like, regarding certain things that have been proffered out there. You might notice that, for example, issues 6 and 10, you probably have never heard before. Because as far as I'm concerned, I'm the only one that has ever discussed them anywhere. Although the basic issues have been known, trying to put them in context against an unguided process, which is what I would be referring to in the universal notion of evolution, rather than just the biological aspect, which is one facet of it. I don't find a basis scientifically for an unguided process because of the conflicts that I see. And I could add to these, this is not a case of I've only found 16. I have another batch of 16 ready for a young 16-year-old right now to work on, and I could produce hundreds of others without any trouble at all. So I hope that answers. Do you have another comment? Okay, try. I'm sorry, I didn't answer. You have. We have to end.
Eventually, but go ahead.
Okay, please. I'm sorry I didn't answer. Please, Frank.
Do you believe that the God of the Bible is true?
If I remove myself from outside the empirical context and speak there, yes.
So you don't need evidence to make that decision? It's yes?
I would say that by process of elimination, I don't even need to necessarily refer to the scriptures in order to come to the conclusion that the only choice is that one, and all the others don't make any sense. But I leave it to you and to the others as to whether or not I've eliminated those choices properly.
You need another talk or two for that.
Well, perhaps yes, but that's not the purpose of this one. The purpose of this one is to eliminate the things that don't make any sense.